Hello, this is Eric with Eric's Gear, and I'm doing something a little bit different this time. So today we're doing a little bit of programming, some software development with a problem that was I first saw, well maybe not first saw, but that I saw a friend bring to me, coworker, when he was doing night school online through Harvard of all places. Um, Really cool guy. He came to be a really good friend of mine, and so he knew that I had a lot of experience doing software development, and he brought a matrix, a table like this, to me, and he was wondering how best to solve this. Um, and the key idea was to use as few iterations, as little code as possible, just to reduce processing of something like this. Um, so I'm going to show you one of the things that I suggested to him. This was like 8, maybe 12, 10 years ago that I talked to him about this, and so I don't know exactly what I told him, the whole story, but I do remember telling him some of this, and I'm going to also go into a little bit more detail than I think I gave him. So let's just start off here. This is a basic multiplication table. Um, and so there's actually a lot of redundant data in here. The first thing I showed him, which, uh, as intelligent as he was, I was surprised that he didn't notice this immediately, is that over this diagonal here, everything is mirrored. So you got 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and 2, 2, 3, 3, 4, 4, 5, 5. And you can do this 6, 6, 8, 8, 10, 10, 12, 12, 15, 15, 20, and 20. So right away we can get rid of um, like the majority of this row, about a little over half of this row. We can get rid of those two. We can get rid of that one as far as duplication goes. We don't have to calculate that. We already know that information from already calculating the other half of it. And the centers, or the diagonal there, is just a squaring of those numbers basically. So I've already got a little bit of this started. I have setting up that table. So I did just a little bit of HTML here, seeing as I'm doing this in JavaScript. And that's just for simplicity's sake. I like to do a little bit of HTML with the JavaScript just so I can do this in a browser. I really like JavaScript because you can go to pretty much any computer and just start doing JavaScript without having to download anything, without having to install anything. A fresh install of almost every operating system will have JavaScript built into it along with the browser. And you can just start programming with no setup. And so that's the way I like to teach people programming when I start programming, because yes, JavaScript is of a fairly high level language, meaning that it looks a lot like English. It's also very complex, but also can be used very simply at the same time. So you can do any real small stuff from the typical hello world to just massive APIs and that sort of stuff through Node.js, because Node.js is a runtime environment rather than a language, and the language that it uses is JavaScript. It also can use TypeScript, and TypeScript is just a strongly typed version of JavaScript. It has grown a little bit more than that, but it was basically started as a strongly typed version of JavaScript. So you can do a lot with JavaScript. And so I'm going to show you a little bit of what I have done so far with this. And I'll go from there. So I am using Visual Studio Code, VS Code. I could be using something like Notepad or Notepad++, but this gives me different things like syntax highlighting and being able to manage my files, do simple stuff like that, a lot easier than Notepad or Notepad++. But those are definitely options to go with. Since I'm not going to be doing much with my 3 files, and in fact I've already got them open here, I am just going to hide that and look at the code here, just for simplicity's sake. So I have right at the top here 2 arrays. They're integer arrays, and that is our header here and our column here. A happens to be the columns or the rows rather, and B happens to be the columns. We can check that out by changing 1, and it shows that 11 showed up here, and we put it 11 in the B array. So that's just a sample of what I've got there. To set the table up, I've got a variable for the table data. That is going to be the rest of this, minus this column. So this is one of the variables that we're going to take a look at quite a bit. Now, this table space is just the table that I had set up. I gave it an ID and a class name, and the class name is the styles. So we have just a little bit of margin around there, so it's a little bit easier to look at, and border collapse so that it has a single line instead of a double line around each cell, making it a little bit more simple to look at, to read as well. So for the table, I also did bold for the headers so that we could see that a little bit better. So that's the bold, and then we can also see that I gave it a nice, easy to look at width, so we don't confuse the numbers here. And this is just the 1 pixel of the border, and I'm doing a text align of center so you can again read this really easily. And that's really all I'm doing with the HTML, and the styles is making this look somewhat readable. And then we're doing the onload of fill table, which is our method right here. So there's the setup for you. With the table data, at the moment I'm just setting up an array here, so that we have some place to put the data. And for the table data, I am just pushing in the A for index and the B for index multiplied by each other. So that is creating the 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. It's just multiplying the rows by the columns here. And for kicks and grins, I have this count variable to see how many times this runs. So for every time that it calculates A times B, it increments our counter, and then it displays it down here, which for the 5x5 grid is 25. So that's something we're going to take a look at in a little bit. And then down here, I'm creating the rows and the cells so that I can display all of this information, but that's not really what we're worried about. So what I'm going to do is I'm going to abstract the visual aspect of things right here from our business logic. And so I'm going to create another method here. I'm going to end that method, and then I'm going to call that, and that shouldn't change our setup over here at all. So now the next step I'm going to do to clean this up, in fact that needs to be down here, and this actually works because I don't even need to use this at all. With the way HTML and JavaScript work together, I don't have to do. I hate pop-ups because they do exactly that. They pop up directly over what you're trying to click on, and then you click on something you did not intend on clicking. Anyway, so we can leave that variable off, save that, and we get the same exact results. Personally, I like having this variable so you know where it comes from, basically. Now, I don't always use it for like C#, Maui, that sort of stuff, but it's one of those habits that I haven't yet eliminated from my JavaScript. I just like to see that the variable is created for my HTML DOM element, and it's just habit at this point. So another habit, just like getting this table display into its own method, I'm going to move this to its own method as well. And so business logic is what we call the actual manipulation of data on an API. So that's what I'm going to call it here. So let's see, that dot that turned into an X says that it's not saved, so I'll save it. Go over here, same exact results. So now we can just concentrate on this bit of code because it's a little bit easier to read knowing that you're only dealing with this part of the code and not all of it. So have code folding. Ooh, it does. Alright, so I'm going to get rid of that. All right. And that is just simply hiding the code so you don't have to look at it. It's still there. In fact, just run it again and we can see that it still works. So, one of the first things that you can do with making this run faster is, like I said, not calculating all this other stuff. So, what I'm going to do is instead of do B length, I'm going to do I. And I'm going to also do less than or equals to I. I'm also going to create a variable here. All right. Let's see if that works. Okay, so we got some of that to work. So evidently this line isn't working. Oh, and the reason why that didn't work is because I used the wrong variable. It also didn't work because in order to fill in this other side, I need to reverse our indices. So let's see if that works. So you got 5, 5, 10, 10, 15, 15, 20, and 20. Okay, so we've got 6, 6, 8, 8, 12, 12, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So yeah, that all works. And the reason for this variable is so that we only calculate it once, but then we insert it into our arrays, the same value into the array, without calculating it. So let's see if that changes anything. Nope. So this right here shows you that if you are calculating a value that is mirrored over a diagonal like this, you can just swap those indices and it will put that in for you. Now, if you're familiar with this sort of thing, you're saying, okay, so you're calculating this value, but then if I and j are equal, then you are, when I add this back in, I'm reassigning the value to something that already has that value. So we can fix that. So in JavaScript, there is a double equals, a triple equals, a not equals, and a not double equals. Confusing, I know. But a triple equal, a double equal says if they are the same. You can have, since JavaScript is not a strongly typed language. You can have an integer 1 and a string 1, and the double equals will consider them to be equal. If you try to do the string 1 triple equals the integer 1, it will see that the data types are not the same and tell you that it's not equal. Same way it goes with the not equals and the not double equals. Because the not double equals is the equivalent to the opposite of a triple equals. Not equals, where bang equals, exclamation point equals, is what's going on here. If so if I does not equal j, then go ahead and assign that value. So if we're on that diagonal, then we're not going to assign the value because we have already assigned it here. So let's just double check that. Nothing has changed, and our count has actually originally gone from 25 down to 15. So you might wonder why that's significant. Well, that's 10 times that this loop has not happened. Where that really gets significant is not with small numbers like this, or small arrays like this, but larger ones. So if we make our data set larger, now we have increased our count to 55. And that's with doing it this other way. If we get rid of this and we go back to if I can spell length correctly, they should have the same values up here, but now we have done our loop, our calculation 100 times. So that's a difference of 45. Now, again, this is still small. You can see how going from 1 through 5 to 1 through 10 in both directions goes from, but by going from 1 to 5 to 1 to 10, we have increased our loop count from 25 to 100. But then if we add in our logic here to make sure that it doesn't duplicate, we drop it down by 45 in this case. We drop it by 10 in the other. In the smaller 1 through 5. So you can see by doubling the direction in each axis of this table, we have added 40 more calculations if we leave it like this. So that's actually pretty good. But here's the next thing. If we also want to save the amount of space that we're using, the amount of memory that we're using for this, we can cut out this second part altogether. So now we've gotten rid of that data, but we've still got our 55 count. So then how do we display this data? Well, we come back to this table, and right here is where we are actually displaying. If we highlight that variable, we can see we are using that variable right here to show the index of I and j. So this is where we need to make the change. Let's create another function. So we are going to get rid of that, and we are going to return it here, but we need to get those variables in here. So we need I and j to be passed in. And since this is JavaScript, we don't have to declare any data types. Alright, so by adding that little method, we shouldn't have changed anything. And again, we haven't changed anything. So now, how do I get all that data out here without adding the data? So what we can do is if I is less than j, j, j equals I. We're basically just swapping I and j. And in fact, I should be using temp here so that it gets the original value of I. So let's see what happens here. And we get all of that information back without having to store it. So you might be wondering why we would bother to do something like this. So for speed reasons, we want to do as few calculations as possible. In fact, this right here, once it's interpreted, this value variable does not actually get created. It is smart enough to take this and just throw it in there without me having to do it like I just did. But I can go ahead and do that and get rid of one line of code. There's reasons for that with code readability. Sometimes you want to have those extra variables there, sometimes you don't. This time we don't need it, so let's get rid of it and just make sure that it's still there. Now you might wonder why we wanted to create this variable or this method and to add logic to it when we could just simply put that data into the array. Well, with this count, we can see how many times that we have used or used an integer in the array. So this right here, if we have limited amount of space like in an Arduino, we have to worry about memory size. So you'll see one of my tabs up here is memory size. We can see that in JavaScript, our memory is for a number, which is what our values here are. For every single one of these numbers, it is 8 bytes. So when we have a full table like this and our count is 100, we are using 100 times 8 bytes, which is 800 bytes. And that's almost a kilobyte. It doesn't sound like a lot until you have to worry about small computers, embedded machines that don't have a lot of memory in them. Okay, after resizing a few things, we can see our list of Arduinos and our list of memory here. So our SRAM is the value that we are looking for. So if we have a Arduino Mini that we're programming for, we only have 2 kilobytes worth of memory that we can run our program in. And that includes data like this. So we saw earlier that for every integer that we have here, and there's 100 of them, that would be 2 bytes. So 200 bytes of memory would be going for this table alone. That's 10% of your memory for an Arduino Uno Mini. That is a massive amount to be using for something as simple as a data table like this. Now, with this count variable, we have found that we are only actually using 55 instances of an integer. So we have dropped our data requirement almost by half. And this gets pronounced more and more when we are creating larger data sets. If I was to duplicate this, now we have 210 instances of an integer, and that's with our reduced data set. If we swap this back to b.length, that 210 goes up to 400. So again, just by changing how we calculate this data set, we can use a whole lot less data. So calculating data and reducing the amount that's used is really important. What we can also do is reduce the amount of data stored in our code as well, because all of this is stored as an integer as well. So each one of these has 20 instances of an integer. So for just these two variables alone, we're using 40 instances, which is 80 bits of data. So let's just not use that. Since this is just duplicate data here between A and B, let's get rid of B. And we can see that the only time that we use B now is right here. So we can reuse A. We can get rid of B. We can we do use B here to set up our grid, and also here. So let's see how this looks. B is not defined. What instance of B did I miss? That one right there. Okay. So B is gone. That means 40 bytes of data that we can use for something else. With A and B and a full calculation of all the data, that would be 440 instances of an integer, which would be 880 bytes. And with the data that we saw over here earlier that is now gone because I resized it, we saw that we only had 2 kilobytes, or around 2,000 bytes to work with, and that A and B and the full calculation takes almost half of that. Now we are looking at 210 instances plus the 20 in here, so that's 230. That's 660 bytes. That's about a third of, less than a third of that total amount of data, and the amount of RAM that we have to work with an Arduino Mini. So there's still a lot that can be simplified here. I'm not going to go into all of it, but we can definitely see that we have improved this code to run a lot faster, with a lot fewer iterations, using a lot less memory, even if we do have to add a bit more code. But I hope this is useful to you in the future, because there's a lot of different times when you're using a lot of data and it happens to be duplicated quite a bit, and this will help you reduce the amount of data that you use, as well as the calculations that go into it. So I think I'm going to stop rambling here, and I'll see you next time.